information that I have. Channel slope N is 0.030. How? The concrete channel. That's the number for concrete. Q or flow or discharge, cubic meter per second. Don't panic, CMS means cubic meter per second. B, 5 meter. It says what is YN, what is YC. So what I just told you, Brock, for normal depths, use one of the Manning or Shezzy. Since I have N and I have S, my choice will be Manning. When it gives me material, most of the time I will go for Manning. A, R, 2/3 S. Just double check the units, it's metric, so 1 is okay here. Otherwise 1.5 or something. 100 here. Or I want to start from here because I have nothing. And I'm going to start from finding a area. When I have Manning, for sure, I will start finding these three. B, Y, Y, 2, Z, or no, it's a rectangular, so I don't need even to use that. Yeah. B plus 2Y, A over P. Do you have B? Yes. And I will start writing N because it's normal depth. 5 plus 2YN are 5YN over 5 plus 2YN. Now 100 is here. That's here. Area is 5YN multiplied by R is 5YN and P is 5 plus 2YN. 2/3 root square of S. There's another version that you can write, which is this one. If you look at it, you have 1 here, 2/3 here. So you can say 5YN 5/3 over 5 plus 2YN 2/3. Multiple by this one. Let me see if you can find the YN using your calculators. What was NF I mentioned there? And the question says find NF. What's that? NF. I just told you that it's weird that it's root NF. Levi, what's NF there? What are you talking about? We never talked about it, but we show it with another thing, like FR. Oh. Yeah, Froude number. I don't know why the book says NF. Number N stands for number, F is for Froude. What? Yes. Yes. They show it by NR for Reynolds number, which again I believe is weird. Did you find why? It shouldn't be that hard using your calculators. What's the answer? If you are between 1.5 and 2.5, your answer should be correct. So what's yours, Brock?
2 point.
Yeah, that's the one. 2.31 meter. So we are done with the first part, the normal steps. I will back to this slide, but before I continue, I will go to the first slide I started here. Do you remember for critical flow, I gave you two situations, rectangular, arbitrary, and the ones that for rectangular, I'm going to use these ones. Okay, back to here. Here we go. Second part. Critical depths, YC. For YC, this is the rectangular, so I'm going to use the one that I have. Q2 over G3 is YC. So YC is equal to, do you have Q? No, but you have large Q and B. Square over 9.23. So find YC here as well. YC for rectangular is the easiest. You have a very small equation. What's YC?
Three point four.
3.44 meter. YC is more than Y of normal because this one was 2.31. This one is Tracy. Based on this, do you think the flow is subcritical or supercritical? Subcritical? Yeah, that's what you think? Okay. You can change your mind whenever you like. Isabella, what do you think? Subcritical or supercritical?
Super.
It should be supercritical. Look at here, we are in this line. Because in this line, yn is less than yc. So for sure, Froude number should be more than 1. And I don't want to make it wrong, but start finding that I don't have FR here, but we can do it right now. Velocity over GD. For rectangular, you are allowed to use GY, right? So find that one for me. For V, you can write Q over A. And for this one, G, Y again. Q was 100, BY was 5 multiplied by 2.31 divided by root square of G multiplied by 231. Find this one for me. And I don't know what to answer if it's more than 1. I hope that it's less than 1, sorry, because it should be more than 1. Brock is fast at calculating. Find this one for me. Why I use 2.31? Because for Froude number, I should use the normal depths. YC critical depths is not something that I use it normally. It's a specific situation.
One point eight.
Yes. 1 point,
Eight.
as you can see, it's more than 1, which is super critical. It didn't ask you, but I need you to be able to analyze that because next chapter, you just work on these ones. Let's go to the next one. I think that's the solution for you. Oh, here, yeah, Froude number, I have it, but I didn't write it here for myself. And it says note yn is less than 1. See. Next one is the same. I just make your life harder because I changed the cross section from rectangular to trapezoidal, which nobody likes it. So write the information. This is question, this is question. M and Z are the same. Just want to make sure that you are familiar with the different letters. So 1.5, B 25 feet. Discharge 1510. CFS stands for cubic feet per second. And this one, which is S or S of channel. If you look at it, this one is a like large channel because the water that it can pass, it's like 1,500 or something. Width of the channel is 25 feet, which is huge. And the slope is pretty slow. So all the signs shows that it's a huge channel. Tanner, what should I use to find YN or uniform flow depths, normal depths? We have N as well here. N is 0.0.
I don't know.
I like you're brave enough to say. 4. Uniform flow for normal depths. Always Manning or Shezi. Never ever forget it. This is the first step of solving the problem. If you're stuck there, you will stuck for the rest. R 2/3 is fine. Okay. And I would like to change it a bit. If you agree, I will write it like that. Both are the same. I just write it to make sure that you see different versions. I open R here and make it like that. I have Q, I have N, I have S. I don't have area and P. So I will start from here. Area BY plus Y2Z. P B plus 2Y squared. Or M, doesn't matter. Z, M, both are correct. Do I have y or yn? No, so I will just keep it. Yn plus y square n multiplied by 1.5. 25 plus 2 multiplied by yn plus I don't have it. 15, 10. Be careful. That's a British system. So add this here. It's not SI. Okay, make the correction here. I just double check and notice that it's not SI. 1.49 over 0.017 multiplied by 25 by n plus 1.55. From here, you should be able to find yn. If you have your calculator, at least try to see if you can solve it or not. Did you find yn? In case in the exam or assignment, if you can not use your calculator to insert the equation and get the yn, you should start giving numbers. So make your equation as simple as possible, then start giving different number to yn. That's the traditional way of doing that. But my suggestion for exam, you should be able to work with calculator and give it the equation, get the yn. Otherwise, it takes time. So I don't want you to lose time on this one. What's your normal depth? Tracy, what's yours? Okay. Brock,
6.21.
I told you he's fast. 6.25. First part done. I'm going to find critical depths. Jesse, which equation should I use to find critical depths? No. Which one? I think, yeah, if I hear you correctly, yes. The one that I said that if it's rectangular, use that one. If it's another cross section, use that one. So it's not rectangular, so you cannot use the simple one. Q to T over GAC should be equal to 1. That's the one, yeah. And I can put C here because I'm looking for critical. If you would like, you can do that as well. What I need T and I need A. So AC equal to BYC plus square C multiplied by Z. Don't use the Y that you found last step. That's normal depth. You are looking for the YC. So B was 25, right? 25 YC plus 1.5 square, not a square, sorry, YC. There is the YC. T. B plus 2YZ. That's the equation for T for trapezoidal. 25 plus 2YC. I don't have it. 1.5, which is 25 plus 3YC. That's TC. Now I just need to put everything I have. Q was 110 multiplied 25 plus 3YC. 32.2. Be careful. It's not SI area. 25 YC plus 1.5 C squared. That by 2 should be equal to 1. So find YC from here. Probably you should get 4.41. Your right hand was 6.25. Zach, is it a supercritical or subcritical? yn is more than yc. Is it supercritical or subcritical? Again, you should imagine this one. That's yc. So yn probably is somewhere here. Subcritical. So correct. If I calculate fr, it should be more than 1 or less than 1. Is it? It's subcritical. Less than 1. And these are the answers for this one, which I will post it.